The pages in your booklet that are relevant to this section for graphing inequalities will be pages 17 and 18. Let's look at example 1. We have y is greater than 3x plus 2 and x plus 3y is less than or equal to 6. The first thing you want to do is make sure everything has the y equals form. So y needs to be by itself. To do that for this one, we can subtract x from each side and divide by 3. So you still have y is greater than 3x plus 2. And then we have y is less than or equal to negative 1/3 x plus 2. Let's go ahead and plot these points. So if we have an m equals 3 and b equals 2, let's start that. So here's 2. Your slope is 3, so up 3, right 1. And we can also start b and go down 3, left 1. I'm putting holes instead of points because there's no line under there. And then we could plot the other one. So we have our starting point 2 again. And there would be up 1, left 3, up 1, left 3, and so on. Start back at the starting point again. B, down 1, right 3. Down 1, right 3. And then we have filled in points here because it has a line underneath the less than symbol. So from here, we can go ahead and shade these in. The blue one will be shaded above the B. So any y's that are above, we'll go ahead and shade that in. If you're confused about where you shade above or below, you can also do a test point, such as 0, 0. For the second inequality, it has less than or equal to, we're going to shade below the B. Now the solution set will be where it's shaded for both inequalities. That would be this part. So that would be the solution region. A good thing to remember is if you have y is greater than, you'll shade above. If you have y is less than, you'll shade below. Below the B and above the B. Now this only will work if you have y by itself on the left side. If you use a test point such as 0, 0, it will work regardless if y is by itself or not. Try that next one. Now let's look at example 4. We'll say the first inequality would be the blue one, and the second inequality will be the red. So the blue one, we have y is greater than or equal to x plus 1 squared minus 3. That's a quadratic in vertex form. Let's find the vertex. It's negative 1, negative 3. Negative 1, negative 3. So that's your vertex right there. It's going to be facing upwards. So we'll go ahead and do that. Now let's go ahead and do our test point. 0, 0. Is 0 greater than or equal to 0 plus 1 squared minus 3? Is 0 greater than or equal to 1 minus 3, which is negative 2? That's true. So we're going to shade this side with 0, 0. If it was false, you would shade the opposite side. Let's look at the red one. It's a linear. So we have m equals 1/2 and b equals 5. So our starting point is 5. We're going to put a hole. Down 1, right, or down 1, left 2. Down 1, left 2. Down 1, left 2. So on. Okay, we have less than with y by itself. That means it's going to be shaded below the b. So anything below b equals 5. Now the part that is the solution is the part that is shaded for both colors. That's this part right here. Now if you didn't have a calculator that shades the solution for you, again, do your test points. Or if you have y is greater than, you shade above. Y is less than, you shade below the b. One or the other. Either test points or one of these properties. Now if you're given a table, you would find where the two match. So -2, -2, we don't have that. We don't have that. But these numbers are the same, so this would be your solution. Let's look at the next page, page 18. So we have more graphing. So on the calculator, go ahead and put each of them in y equals form. Y is f of x in the TI Inspire. You need a graph to solve the systems. Now, there's test restrictions on a lot of the TI Inspires that won't let you use inequality symbols, and they also won't let you have it in standard form. That's why it's important to know how to put it in these forms. Now, if you're using the Desmos calculator, it won't matter what form it's in. Let's go ahead and graph these two. So we'll say the first equation is blue, second one's red. So the blue equation we have b, or let's say m first. M, your slope is 1, your y-intercept is 4. So we'll start at 4, 2, 3, 4. And then we're going to do the slope of 1. Up 1, left 1, up 1, right 1. So up and over 1 basically. And then you just draw the line. And then we'll do the red one. So your slope is 2, your b is -1. So we start at -1, up 2, right 1, up 2, right 1, up 2. And then we're going to draw a line that goes through this. Notice they intersect right here. The intersection is at 3, 4, 5, 5, comma, 1, 2, 3, 4, 5, 6, 7, 8, 9. 5, comma 9. So your intersection, your solution is 5, comma 9. And now let's look at this example. Y equals x plus 2. We'll say that's blue. M equals 1. B equals 2. And then our red equation, y equals 9x minus 6. M equals 9. B equals -6. So let's graph these. So let's start at -6. Up 9, we'll write 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1. And then let's do our B. So start 2, up 1 over 1, up 1 over 1, and then draw your lines. Okay, then we're going to draw our line to go through it. And then our red line. And then our intersection is right here at 1, 1, 2, 3, 1, 3. So your solution is 1, 3. That's your intersection. So keep practicing graphing these. You can also graph these in the TI Inspire calculator by doing this, or you could graph it on Desmos. Alright, now let's do some of the practice problems for practice 3D, 3F, and 3G. 3D is determine the reasonableness of solutions to systems of linear equation and quadratic equation in 2 variables. So we'll do one of these. Determine if the point gives a true statement for each equation. Let's look at number 2. Let's see if point -1, -3 is a solution. To be a solution, it has to be true for both equations, not just one, but both of them. So let's plug that in. 2 times -1 squared minus 5 times -1 minus -3. Does that equal 0? Okay, we have 2 times -1 times -1. That's just 1. So we have 2 plus 5 plus 3. Does that equal 0? No. So the answer is just no. If you get no on the first one, you could just stop there and say no. But if, let's just say you got yes, you would want to also plug it into the next equation to see if that's true. Okay, -1 plus -3 is -4 plus 2 equals -2. That is not equal to 0. That's definitely a no. Do the same thing on each of these other 3. 0, 0 is usually the easiest point to test. Okay, let's look at these somewhat off-topic questions. Write the coordinates for this point. They're talking about this point right here. So, this is the origin 0, 0, 0. We have up and down for Z, left and right for Y, and then forward backwards for X. The axes may not always look like this with different programs. So be careful of where each axis is. Sometimes they have Z here, sometimes they have Y here, and so on. So let's look at this example. So we know that it's going to be over here for the X values. So it went forward 3. And then it goes up a certain amount as well. It's going to go up 2. And then let's see how many it goes to the right. It goes right 4. So right in this case is Y, up is Z, and then forward would be X. So we're going to have all 3 positive numbers. We'll have 3, 4, 2. And that is your coordinate point for this point on the box. Let's look at the next one. Plot each point. So we have X, Y, and Z. So the -2 means that it went back -2. Or back 2 basically. 4, it went right 4. And then the Z -3, it went down 3. So let's go ahead and just like sketch that out. So we have a -3 down here, back 2, and then down, or right 4. So let's go ahead and sketch this out. So let's draw some lines to show some depth. And then this is a sketch of the picture. Okay, let's look at 3F. Solve systems of 2 or more linear inequalities in 2 variables. So you can still do those Delta Math assignments and EDIA. You could do those for extra credit, or if you would like to get extra practice in, or if you lost your packet. So let's look at these. Sketch the solution to each system of inequalities. So for this one, let's say that we have the blue one and a red one. So the blue would have a slope of 3 and a y-intercept of 3. Let's go ahead and write that in. So we have 3 with the hole, down 3, left 1, down 3, left 1, down 3, left 1. And then we could draw our arrow. And then we'll do the red one. So the slope is 3 and the y-intercept is -2. So start -2, up 3, right 1, and so on. And then draw your arrow. They're both dashed lines because they have no lines under the inequality symbols. Now from here we want to shade in the value. So y is greater than. Since y is greater than for the blue one, we're going to shade above the B. So we'll shade on that side. The red one is less than, so we're going to shade below that. Now notice there is nowhere that is shaded with both colors. There's no purple here. So that means there's no solution. Now parallel lines might not always necessarily be no solution, but it is in this case because there's no purple. Okay, you'll work out these other problems similarly. Graph them, shade them in. Whatever part that's shaded for both of them is the solution region. Let's look at 3G. Determine possible solutions in the solution set of systems of 2 or more linear inequalities. Here's Delta Math, here's EDIA. You could do those as well for extra practice, for extra credit, and so on. Let's look at 19. Is 0, 0 a solution to the system? It has to be true for all three. If it's not, then it's not a solution. Let's check. So is 0 less than 3 times 0 plus 12? Is 0 less than 12? Yes. That's a yes. Okay, let's try the next one. Is 0 greater than 0 minus 4? Is 0 greater than negative 4? Yes. So that works too. Let's look at the last one. Is 0 greater than negative 1/2 times 0? 0 is not greater than 0. They're equal. So that doesn't work. So we'll put no. So if it doesn't work for even one of them, it's a no. It has to work for all of them to be a yes. If you're given a system, you can also determine if a point is a solution. So 0, 0 is a solution to the system. This is a yes. Anything in here would be yes. 1, 0. Is that a solution? Yes. 0, 1. Yes. 0, negative 2. No. And then you would complete the rest of those. Graph them on the graph provided, like plot these points to show some work. For the rest of these on the next page, you're choosing either 1, 2, 3, or 4. So instead of A, B, C, D, it's 1, 2, 3, 4 for these. It says, which ordered pair of the solutions set of the systems of linear inequalities graph below? It's talking about this part that's cross-hatched, this stuff. So, 1, negative 4. That looks like a yes. Okay, negative 5, 7. That's somewhere over here. That's a no. 5, 3. That's like right here. That's no. And then negative 7, negative 2. So no. So the answer is 1. Plot the points to show some of that work. You could also go over the crosshatched part with a different color, a highlighter, a colored pencil or something, to show that you know that's the solution region. Remember, you could check the answers in the back right here, on the back of your packet. Again, don't just copy these. I want to see the steps for you to get full credit. And also take a moment to reflect on Unit 4. On the back of your packet, the very back, fill out your reflection. Summarize what you learned from this topic. What questions do you still have about this topic? If you want this answered like right away, send me a message on Remind. How are you studying in class? Are you asking your peers for help? Are you asking the teachers for help? Are you looking up online resources? Are you practicing the online practices, the cherry quizzes, doing additional notes, practicing stuff in this packet? What are you doing? Write that down. How are you studying outside of class? Are you redoing the cherry quizzes, making higher grades? Are you looking at what you missed before? What are you doing? What are some new study techniques that you haven't tried yet? Have you tried the Delta Math assignments? If not, maybe you could try those. Have you tried the EDA assignments? Maybe you could try those if you're still needing some extra practice. Remember, to become proficient in something, the average student needs to spend 2 to 3 hours for every hour in class working on course material. That means you should be working on stuff for this class 9 to 14 hours outside class each week. Did you study outside class for 10 or more hours? Yes or no, be honest. And then create a plan for making time for 10 hours of asynchronous work for this course per week, or maintain that amount of time if you're already doing this. Now, if you're already successful, you're getting like straight 97s, then whatever you're doing now is working, even if it's less than 10 hours. If you are struggling, if you are failing every test, and it's less than 10 hours, I would say definitely create a plan so that you get those 10 hours in each week. List some goals for the next unit, and how could the next unit be better? What would you like to see added or changed to this?